Hello everyone, I'm so happy to welcome you to today's class where we would explore the essential concepts of logical operators, specifically logical and logical on. So today guys, we're going to deal logic or we're going to go in depth into logical and logical or. So in the last class, we talked about logical and, logical or, and logical not. But today we're going to go so in depth into logical and or because they're the ones that are commonly used in the world of development. All right. So this lesson is designed for those who are completely new to programming and logic, and we'll take our time to ensure that everyone understands these foundational ideas. So guys, let's us get started. All right. First of all, what are logical operators? For a recap, because we already discussed this in the former class, logical operators are fundamental tools in programming and mathematics that allow us to make decisions based on conditions. They allow us to make decisions or make choices based on conditions. They evaluate expressions and determine the outcome by making use of the Boolean value. Of course, we all know what Boolean value is, which is either true or false, right? So in programming, logical operators help us control the flow of our programs by allowing us to make decisions. For instance, guys, you might want to execute a certain block of code only if specific conditions are met, right? You only want to execute that particular block line of code only if a specific condition is met. So today we'll be focusing on two logical operators, which is the logical and the logical on, all right? Which is this, the logical and, which is this, and the logical or. Okay? So by the end of today's class, guys, you should be able to understand what Boolean values are and their significance. You should be able to understand, you should be able to read and interpret truth tables for logical and logical or, and you should be able to recognize the concept of short circuiting in logical operations. Alright. First of all, guys, what is logical or rather what is Boolean values? What are Boolean values? Now you heard of the word Boolean values. Of course, we already know that Boolean values is always true or false, but let's go in depth to what Boolean values are all about. And let's start with the basics. Boolean values are actually named after the mathematician George Boole, who developed a system of algebra based on binary values. In simple terms, Boolean values can represent two states. Yes, they can represent two states, which is either true, which is often represented as one, that is what you can see here, often depicted as one, or false, which is depicted as what? As zero. So normally, if you remember me talking about conversion, string conversion, and or Boolean conversion. Booleans, that is true or false. True is always one and false is always zero. Okay, so you can think of them like a light switch that you can turn on. So it's either you turn it on, which is true, or you turn it off, which is false. And these values are crucial in computing because they form the basis of decision making in our lives or in programming. All right, and we have a few importance of Boolean. Now, Boolean values are very essential because they allow us to create logic, or rather, they allow us to create logical expressions that can evaluate conditions. For example, in programming, you might want to check if a user is logged in before allowing them to access certain features of the application, right? And this is where logical operators comes into play. Without you having logical operators, you can actually check whether the user is logged in or not. All right. That is why it is very, very important for you to understand the logic behind logical operators. And then we also have the truth tables, which are a systematic way to represent all possible outcomes or combination of inputs for a logical operation and their corresponding outcome. Now, this particular thing we are seeing, guys, it helps us to visualize how different inputs would affect the results of a logical operator. So it makes it easier for some of us to start cramming all these things into our brain. Or we can just easily just have this logical table at the back of our mind. All right, just have it at the back of our mind. Now let's look at this table, guys, and let me explain it again for you guys. Although I already did it in the previous class, let's do that again in today's class. Now this column here represents option A or condition A, and this one represents condition B. All right. Now for the first one, this is and this thing that's in this A, that's condition A and condition B, right? Now the rule is that if for AND operator, if anything evaluates to true, right, it will give you true. That means if you have a condition A and condition B, or let me say option A and option B, there must be true for you to evaluate to true. If there's anything like false there, it will give you false. Do you understand? Do we understand, guys? Like it's just like me saying that as far as that particular that word is as far as that particular thing has false in it, as far as there's any error, I don't want it. But all the things must be error free before I can accept it. Even if you give me hundred things or hundred say let me say for example you are giving me 100 goods, right? I am buying goods from you. As far as common one, even if it is 100 goods and 99 of the goods are good, but just one is false, I don't want. That is, I'm giving you false, I don't want. But for me to actually collect that goods from you, all the 100 goods must be error free. So same thing in and the operator. As far as there's any false there, whether condition A is has false or condition B has false or they are both false, as far as there is false in any of the condition, it will evaluate to become false. So for it to evaluate to become true, the both of them, all the conditions must be what? Must be true. Do you get? So that's why now when you compare condition A and condition B with the AND operator, it come and check here. Now is condition A true? Yes, it's true. Condition B true? Yes, it's true. It will now give you true. Now look at the other one. A is true, B is false. So therefore, since any of them has false, of which B has false, to give you false. The next one, A is false, B is true. Because any of them has false, of which A has false, to give you false. The last one, A is false, B is false. Because both of them has false at all, it gave me false. Coming to the OR operator. Now the OR operator is the opposite of the AND operator. That means as far as any of the value or condition is true, it give you true. You get? Same thing for AND, as far as any of them is false, it will give you false. So the only way to give you true is if both of them are true. Same thing the opposite. If for the OR operator, if any of them gives you true, it will give you true. But if both of them give you false, it will give you what? False. So looking at it now, we have the A or condition A. A is true, B is true. So therefore, since the both of them has true, it gave me true. Now coming again, A is true, B is false. As far as any of them have true, of which A has true, to give me true. Coming again, A is false, B is true. As far as any of them have true, of which B has true, to give me true. And the last one, A is false, B is false. Now none of them has true, so therefore it will give me what? False. So that is how this truth table works and how it is explained, guys. It is as simple as that. Alright? It's as simple as that. So now let's go to what we call short circuiting, guys. Now we understand what truth tables are and how they are used, right? Now let's talk about a behavior called short circuiting. Now this occurs when evaluating a logical operation. Now this occurs when you are trying to evaluate a logical expression and it stops as soon as the outcome can be determined by the first operand. What do I mean, guys? Let me go to my code and explain because there's no way you understand what I'm trying to say just by theory. Now, let's say for example, guys, consider this expression. Let me come to my code here. Let me take this off. Okay, let me come take this off, and then let me come here. Okay. Now, guys, now let's say for example, now consider this operation, this expression, right? A as A is condition A, then we have and then we have condition B, right? Now if A is false, all right, I mean if A is false, we don't need to check whether B is false because we already know that the entire expression will become false regardless of B. Are you seeing what I'm trying to say? That's when we're talking about the AND operator, guys, the AND operator. The AND operator. As for the AND operator, you know that we said that as far as there is that the only way it will give us true is if all the conditions are true, right? That means both condition A and condition B must be true for the AND operator to actually give us true, right? Now if A is false, no need to even check whether B is false. B is true because it will definitely give me false. You know get what I'm trying to say, guys? That's what we call short circuiting. That means by knowing what A is, we already know the outcome of B and what the outcome will be. That means if we have two options, we have option A to be what? To be equal to what? To be equal to true, right? Or that to be equal to false, for example. And we're considering the AND operator. So if we already have A to be false, we already know that whether B is false or B is true, as far as there's already false in the option or in the condition, the AND operator will definitely give us what? False, because it does not care. As far as any of the condition has false in it, it must give you what? It must give you false. Except both of them have true. So except maybe option A now then has true. Then we can ask, okay, good, since A has true, maybe B could be true. Then we can now check for B. You get. But as far as the first one already has false immediately, like this, there's no need for us to check option B, because as far as we are concerned, once there is false in any of the condition, it will automatically become what? Become false. That is what we call short circuiting. So short circuiting just checks for the first option. If it checks for option A and option A gives false, it does not even bother to go and check option B. It just give you false immediately. But if you check for option A and option A is true, then you can consider going to check option B to see if option B is also true or not. And then if option B is false, it will give you false. If option B is true, it will give you true. Do you understand? Now coming to the OR operator this time around, the OR operator, the short circuiting of OR operator actually works this way. If A is true, you don't need to check whether B is true or not. We know that once any of them have true in the option, automatically the answer must be what? True. Just the way if we have A and then we have or B as well. Now if it just goes and check and says that A is what? Is equal to what? A is equal to what? To true. Remember that once any of the option of the condition is true, whether option A is false or option B is false, as far as there is true in any of the condition, automatically to give us answer true. Do you understand? So the short circuiting in all options is that once it checks A and A is true, automatically it will not need to check B whether B is true or not, because once any option is true there, it will give us what? True. So that is what we call short circuiting. This helps us to improve performance in programming by preventing unnecessary complications. You get? Okay, so now let's actually apply what we have learned with some real life scenarios where we can use the logical and or. Okay? Now imagine now you guys want to go, like I said before, you want to go out, right? And then you want to check whether you should go out with an umbrella or not. That means to check whether it is raining or not. Now, if it is raining, right, of which A, let me say of condition A is condition A is it is raining, right? And condition B is umbrella. Okay. Now, if A is true, that means it is raining, right? And condition B is that you don't have to bring an umbrella. What do you think the answer is going to be actually, guys? Let me just put that in code so you get what I'm trying to say. Okay. Now, if it is raining, of which condition A is equal to what? True, right? Now, guys, we're considering the AND operator, not the undo, the AND operator. If condition A is true and you have an umbrella, of which condition B is also what? B is also what? Is equal to what? Is equal to true, right? Then you can go outside. But if it is not raining, of which condition A is false, right? Condition A is false. Therefore, it doesn't matter whether condition B is true or false. Automatically, you will not go outside because it's already raining. Do you get what I'm trying to say, guys? Now you want to go out and you're trying to check whether you should go out with an umbrella or not. And condition A now is talking about the rain. You check outside, it is raining. Whether it is not raining. If it's not raining, you can go outside, right? Do you get? But if it is raining, you cannot go outside. So definitely, there's no need for you to go out with an umbrella. It is that simple, guys. This scenario actually illustrates how both conditions must be met before the action can be taken, right? So it is that simple, guys. It is that simple. So to wrap up our class today, guys, we've learned about Boolean values, which is true and false, and their importance in logic because they are really, really important. And we've also explored the truth tables for logical and logical on. Right. So if you found this class helpful, guys, please make sure to like this video and subscribe for more content like this. And in case you have any questions in that you are finding this difficulty with, just leave them in the comment section and I will do well to reply them as soon as possible. You have a great day and happy coding.